Hi, today we are going to see about memory management. Memory management background. Memory management is a critical function of operating systems that involve efficient allocation and utilization of memory resources. It ensures that processors have access to the required memory for execution and minimizes fragmentation. Swapping. Swapping is a memory management technique where processor part of the processor are temporarily moved between main memory and secondary storage. It helps free up space in RAM by transferring less frequently used processes to secondary storage, allowing more important processes to run in main memory. It is swapping used swapping happened between main memory and secondary memory. So swapping is essential for managing memory contention and optimizing overall system performance. And contiguous memory allocation. Contiguous memory allocation involves assigning blocks of contiguous physical memory addresses to process. While simple to implement, it can lead to fragmentation issues such as external fragmentation and internal fragmentation. External fragmentation is unused memory gaps between allocated blocks, and internal fragmentation is unused memory within allocated blocks. So, paging. Paging is a memory management scheme that divides physical memory into fixed size blocked called pages. Processors are allocated memory in page size units, allowing non contiguous allocation and reducing fragmentation. Paging requires a page table for mapping logical addresses, it means virtual addresses, to physical addresses, enabling efficient address translation. Segmentation. Segmentation divides a process into segments such as code, data, and stacked segments, each with its logical address space. It simplifies memory management by organizing related data and instructions into separate segments, improving modularity and code readability. Segmentation with paging. Segmentation with paging combines the benefits of both segmentation and paging techniques. Processes are divided into segments, and each segment is further divided into pages for efficient memory allocation and address translation. The hybrid approach reduces fragmentation while providing flexibility and scalability in memory management. Virtual memory. Background. Virtual memory is a memory management technique that extends the available physical memory by utilizing secondary storage. That is, example, hard disk, as an extension of RAM. It allows process to access more memory than physically available, improving system performance and supporting larger applications. Demand paging. Demand paging is a virtual memory strategy where pages are loaded into a main memory only when they are needed. It reduces initial memory overhead by loading pages on demand, improving system responsiveness and memory utilization. Process creation. Virtual memory plays a crucial role in process creation by providing each process with its virtual address space. When a process is created, its virtual address space is mapped into physical memory. When a process is created, its virtual address space is mapped into physical memory through page tables, ensuring efficient memory allocation and isolation between processes. Page replacement. Page replacement algorithms decide which page to evict from main memory when space is needed for a new page. Common algorithms include least recently used, first in first out, and optimal page replacement, each with its trade offs in terms of performance and complexity. Allocation of frames. Frames are fixed size blocks of physical memory used in paging system. The allocation of frames involves managing available frames, assigning frames to pages, and optimizing physical memory utilization to accommodate multiprocessor efficiently. Thrashing. Thrashing occurs in virtual memory systems, when the system spends more time swapping pages between main memory and secondary storage than executing process, it leads to severe performance degradation and is typically caused by excessive page faults or sufficient memory allocation. This is the thrashing. So in this video, we have seen about memory, so contiguous memory allocation, paging, segmentation, and what is segmentation with paging, and what is virtual memory, what is demand paging, and how can we create the process, and how can we replace the paging, and allocation of frames, and thrashing. These are all things we have seen in this video. We have seen some other topics in further video. Thank you.